ঠিক আছে, দেখছি।
আচ্ছা
একটু
আচ্ছা
1 মিনিট টাইম লাগবে
ওকে
একটু
ওকে
অ্যাডজাস্ট।
ওকে ওকে
দেখতে পাচ্ছেন?
হ্যাঁ, মুখটা কেটে যাচ্ছে উপর অংশটা। হ্যাঁ হ্যাঁ, নাও ইটস অল রাইট। একটু মানে মুখটা কেটে যাচ্ছে।
আচ্ছা,
হ্যাঁ, মুখটাকে একটু ফোকাস করলে ভালো হতো।
এই তো।
হ্যাঁ ঠিক আছে,
এবার দেখা
ঠিক আছে।
যাচ্ছে?
হ্যাঁ দেখা যাচ্ছে, দেখা
দেখা
যাচ্ছে।
এটা ঠিক আছে। মুখটা কেটে যাচ্ছে কিন্তু মাঝে মাঝে। হ্যাঁ, সময় শুরু করে দাও।
ঠিক আছে, ঠিক আছে। এরপর আর আমাকে দেখতে চাইলে মুশকিল হবে, কারণ তাহলে আর বোর্ড দেখা যাবে না।
না ঠিক আছে, না যখন বোর্ডে চলে যাবেন তখন না দেখলেও চলবে, কোনো অসুবিধা নেই। জাস্ট মানে ইন্ট্রোডাকশনটুকু আপনি থাকুন।
ঠিক আছে, ইন্ট্রোডাকশনটুকু আমি থেকে তারপর আবার ঘুরিয়ে দেবো।
একদম, তারপরে বোর্ডে চলে যাবেন। সোমা, তুমি মিউট আছো?
শোনা গেছে?
হ্যাঁ ঠিক আছে, ঠিক আছে। হ্যাঁ ঠিক আছে, শোনা যাচ্ছে।
হ্যাঁ, আমি এর আগে যে কথাগুলো বললাম শুনতে পেয়েছেন?
হ্যাঁ, না
না আগে শোনা যায়নি।
ও
আগে শোনা যায়নি, এখন
আচ্ছা
শোনা
আচ্ছা,
যাচ্ছে।
ঠিক আছে ঠিক আছে, আমি তাহলে আরেকবার বলছি। Good afternoon to all the participants. On behalf of Radio Physics and Electronics Association, I welcome you all in this today's technical talk on MIMO and beamforming in 5G. Now I will request Professor Ovirup Das Bormon, the head of the Department of Radio Physics and Electronics, to introduce our today's distinguished speaker, Mr. Saibal Gupta. Sir, please.
Okay, thank you, Shoma. We welcome Mr. Saibal Gupta, and we are very happy that he has accepted our invitation to give a lecture on MIMO and beamforming in 5G. I am sure that these two keywords, MIMO and beamforming, many people would not have heard even 5 years back. Okay, but nowadays almost everybody knows these two important term, because this two term is associated with to improve the capacity, data rate of the network. And basically these two keywords are associated with multiple antenna techniques. I hope I am right. It's a multi-antenna techniques. These two, MIMO and beamforming, these two words are associated with multiple antenna techniques. So the lecture will be delivered by Mr. Saibal Gupta, as said, Shoma. So I just give a brief introduction about the speaker. Mr. Gupta, he did his BSc honors in physics from Narendrapur Ramakrishna Mission College, and then he did BTech in RPE in 1984 and MTech also from RPE in 1986. Then he qualified Indian Engineering Service in 1985 and then joined Department of Telecommunications. where he worked in various capacities like installation, operation, maintenance, marketing, and management. And after a long tenure in Department of Telecommunication, he retired in September 2021 as general manager. And thereafter, he has a brief stint of teaching in different colleges, and he's a fellow of Institute of Engineers and fellow of IETE. So with this brief introduction, I invite speaker Mr. Saibal Gupta to deliver his speech. So over to speaker.
Thank you. Thank you, Coordinator Madam. Thank you, HOD, Mr. Obirup Das Borgon, and my brothers and sisters, other faculty members. Today's topic is, as Obirup told, that it is MIMO and BeamForming. But prior to that, I wanted to highlight something about the mobile topology of general mobile network. Just I am coming to board. Generally, this is the common structure of any mobile network. In case of 5G, the mobile handset, it is called user equipment, UE. And then UE communicates with the mobile tower. It is called G node B. And G node B is connected to through transport network to backhaul network, and backhaul network is connected to internet cloud. Now, in earlier versions, say 2G and 3G, there is some problem. Problems I am telling one by one. What is the problem? That communication is serial mode communication. That means data is transmitted serially. But in LTE 4G onwards developments, the telecom scientists thought of getting rid of this problem. How? That is the parallel mode of transmission. Parallel mode of transmission, what benefit is accrued out of it? That is data speed and latency gets increased. How? That I am depicting the next writing. Should I erase any issue? Hello? Hello?
Yes, carry on, carry on.
Acha, acha. So I'm erasing this one. Here in MIMO, the lowest version is 2T by 2R. That means here two transmitting antenna and two receiving antenna housed in the user equipment. That is the lowest version. So what benefit if had there been only one transmitting and one receiving antenna, like in old generation mobile handsets, data would have been transmitted in serial mode. But in 2T by 2R or 4T by 4R or in higher versions, what will happen? Serial data is transmitted in converted into parallel mode. In case of 2T by 2R, this TX1 is conveying 50% data load, and TX2 is conveying rest 50% data load. So within a time period of say t millisecond, this total t volume of data is getting transmitted and the receiver side is getting aggregated. If you compare it with the earlier version, within the T time period, within the T time period, it would have taken 2T time to transmit the total T volume of data. But here, with the development of MIMO, within a time of T, the total volume of data is getting transmitted. So it is the simplest fashion. So with 2T by 2R, the speed is increasing to twofold. Likewise, in 4T by 4R, speed will increase by fourfold. So in this way, in practical parlance, there is 32 T by 32 watt fashion, but at handset level, 32 P by 32 watt is not possible because handset will be bulky and it will not be pocket friendly. So in rural areas, 2P by 2 watt, and in urban and well populated areas, 40 by 4 watt type MIMO is used. Similarly, and it is replicated in receiver side also. And so there is no problem in aggregation of data. And here, what is the main advantage? The data speed and latency gets increased. But still it is subjected to space diversity problem. And second one is polarization diversity. But on the average, if with technology we can overcome space diversity because the out of two transmitting antenna, first antenna transmitter will send data to receiver one. Parallelly, first transmitter will send data to receiver two through diversified path. Similarly, transmitter two first transmitter 2 will send data to receiver 2 as well as it will feed data to receiver 1. So whatever data TX1 is feeding to receiver 2 and TX2 is feeding to receiver 1, that is the diversified, space diverse signal, and space diverse signal may be distorted, may not be distorted. If the signal falls within the Fresnel ellipsoid, then it will not be distorted. And if it falls beyond Fresnel ellipsoid, there is chance of getting it distorted. So that is one issue. Another problem with classical mobile network is, say there is one BTS tower, 3-sector BTS tower. Sectors are 120 degree apart. Each sector goes on radiating within a cell boundary to respective customers. But what happens in practical situation, in all the sectors, there is not uniform population density or client density. Say in some sector area, there is a dense forest or river. In some sector area, there is market. But what happens in classical 2G, 3G, whether there is population density existing or not, the sector antenna goes on radiating their uniformly. Sometimes what happens, during my service period, I have also faced some problem. if there is some illumination issue, radiation problem in some sector, people, subscribers used to complain, and then we have to send a special type of laborers called rigots. They used to climb the antenna and make antenna tilting. See, if the verticality of the antenna is increased, so it will give rise to far-end illumination. And if the verticality is reduced, that means if it is tilted, then near area people cluster will be illuminated. So it is a cumbersome process. So to overcome this cumbersome process, there is some technique in LT long-term evolution 4G and 5G. This beam beam steering technique has been adopted. What is the benefit of beam forming and beam steering? That it is the green technology. That means without wastage of technology, the sector where actual illumination is required, there only illumination will reach, and where there is no necessity, there will not be any illumination. And so it is a sort of green technology. Just a brief discussion about the thing. I am coming to analysis. This beamforming is a technique used in LT, 4G, and 5G, where the radio waves get focused to user equipment in a specific direction. This, what are the benefits? It improves network coverage and network capacity. So here there are two types of beamforming technology. One is analog beamforming, other one is digital beamforming. In analog beamforming, phase shifters are used to steer radio waves in a particular direction, and in digital beamforming, it is digital signal processor to calculate optimal phase shift for each radio wave. This beamforming can be of two types: standalone and non-standalone. Standalone beamforming supports improves performance of 5G network only, and non-standalone beamforming improves performance of LTE, 4G as well as 5G. So along with 5G, it improves performance of long-term evolution 4G. The benefits of beamforming are: it improves network coverage by focusing radio waves where there is lot of demand, like stadium, hospital, concert, etc. It reduces congestion, that is better user experience. It improves network capacity and data rate. It reduces interference as in beamforming, the beam width, 3 dB beam width is very slim. You know the formula of 3 dB beam width, that is 70 lambda by D. It is normally in beamforming and phased array system, Hertzian dipoles are used. Hertzian dipoles are used. What are Hertzian dipoles? You know the Hertzian dipoles, the dipoles whose linear dimension is lambda by 50. So lambda by 50 to lambda by 10. Within this range, the dimension of and dimensional dipoles are called Hertzian dipoles. And those Hertzian dipoles are used in phase shift array. It improves network capability and data rate. It reduces interference. Since Hardian dipoles are used, their slim beam width, due to their slickness, slim beam width, this number of side lobes are there and reduces the possibility of interference. It reduces power consumption of both user equipment and G node B. So battery life of user equipment is enhanced. It is more secure as unauthorized users cannot intercept the data from it. Why? Because again coming to the slickness of beam width, the unauthorized interference cannot crop in. Then it improves both signal strength and signal quality. That means it improves signal to noise ratio. It supports higher order signal modulations. And see here, while discussing the MIMO and beamforming, I am talking the engineering part, structural part of radio network only, not the content part. In content part, there is type of modulations involved like your FBMA, TDMA, WebBM techniques. Those I am not covering because those would have made the session longer. The more is the number of antennas, the narrower is beam. In phased array system, the more is the number of antennas, the less is the 3 dB beam width. And the next coming to digital beamforming. Digital beamforming is having additional benefits, dynamic control to nulls. The nulls, along with main lobe, there are small side lobes also. Those small side lobes give rise to interference to neighboring subscribers. So dynamically it controls the nulls, and then higher resolution than analog beamforming. Normally the resolution issue is not so, this utility is not so important for 4G, 5G. It is important for radar application. The beamforming, beam steering, this is having a wider application in radar technology. Here, beam width is narrower, so higher resolution. This resolution part is especially useful for radar application. It provides flexibility against spatial multiplexing, space diversity. Now, the problem which I mentioned you earlier during MIMO part, that MIMO may be increasing the data rate and latency, but it is susceptible to diversity problem. But with the help of beamforming and beam steering, this space diversity issue can be combated. Next, in beamforming and beam steering, what is the basic principle? The phase lag experienced by successive antenna array members are balanced by controlling phase of input signal current. In case of receiver, delay lines are used to bring all input signals at the same phase. Now, what is the thing? Now, basic question. One basic question is that how one user equipment will come to know which directional beam is to be staged, because their beams are always floating across the cell area, and there are many user equipments existing within that cell area. So there will be a confusion which user equipment will seize which beam. So there is some technique involved. So G node B regularly transmits CSI-RS signal. What is CSI-RS signal? Channel state indicator signal and CSI-RM signal. User equipment on receiving that signal consults its own PMI database. PMI, this user equipment is having one own database. So that database is a table which maintains PMR versus signal to noise ratio. So accordingly, which PMR is suitable against which SNR value, accordingly it selects that PMR. And then is SNR, and that signal to noise ratio is transferred to channel quality indicator. These PMI and CQR values are transmitted to G node B. Here in case of 4G and 5G, the base BTS is called G node B. And accordingly, G node B allots a net beam, suitable beam to user equipment. This PMI data, it is having two components. One is I11. It denotes the vertical position of user equipment, that, and I12, it denotes the azimuthal position of user equipment. You know, in spherical coordinate system there is elevation angle and azimuthal angle, azimuthal variation and elevation angle variation. In Fraunhofer zone, RN zone, there is less dependence on radial component. So user equipment also sends rank indicator signal to G node B towards allocation of beam. Now I am coming a little bit mathematical analysis, how this beam steering takes place. This Huntian dipole, this is the elevation angle, and this phi, this is azimuthal angle. Sorry, this Huntian dipole, let us place at origin. it will, if we calculate the magnetic vector potential and electric field and magnetic field, magnetic vector potential, you know, as per Maxwell's equation, del dot B equal to 0 and del cross A is also 0. So B equal to curl of A, and this A is magnetic vector potential. So any electric field, any radiation in space, that is the fluctuation of magnetic vector potential. From magnetic vector potential angle, if we calculate the electric field, this electric field at a radial distance r will come, I'm telling you, since for a Hertzian dipole, it is a electric field. This is electric field pattern, and magnetic field pattern is omnidirectional. It is a theta angle variation. It is a theta variable, and it is azimuthal angle variation. Magnetic field, it is a E theta versus theta. That is the electric field pattern. And magnetic field pattern is H pi versus pi for theta equal to 90 degree. So it is magnetic field is just azimuthal variation, and electric field is variation as per elevation angle. So accordingly, the expression for electric field comes. I'm just coming short because there is detailed calculation. I'm writing in phasor form. Here, eta is the free space impedance, Es by E theta by H pi. I0 is a constant current for Hertzian dipole. You know, the Hertzian dipole dimension is so small, lambda by 50 to lambda by 10 order. Their current is not appreciably varying as along the length of the dipole. So it is the magnitude, amplitude is always constant. Current variation, this current is always same for Hertzian dipole. That is not the case in case of half-wave dipole, but in phased array system, mostly we use Hertzian dipole. So here, constant current we have taken. Beta is, you know, the twice pi by lambda, and DL is the length of Hertzian dipole. And theta is the elevation angle. R is the point existing in Fraunhofer zone, and from the center of the Hertzian dipole, what is the distance between a point in the Fraunhofer zone and origin of the coordinate system. So accordingly, this electric field is coming theta I0 beta dl sine theta y 4 pi r into e to the power minus j beta r. Of course, there is some phase factor j that I have not written. Here I have written the phasor form. Here time variation is not mentioned. since it is in phasor form. And H field, if you write H field is simple H5 because magnetic field varies azimuthally. So here there will not be eta factor. So excluding eta factor, it will be I0 beta dl sine theta by cot pi r into e to the power minus j beta r. So here one thing is noted. So how phased array radar operates? Note the I0 factor. This I0 amplitude may be constant, but I0 is having one phase factor. This is Hertzian dipole array, say along z axis. Dipoles are placed. Each dipole is having individually donut shape radiation pattern. And magnetic field pattern is circular magnetic field pattern, omnidirectional magnetic field pattern. But the moment it is put in array, there will be beam coupling, pattern multiplication. So here it is this, 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 like that. So it is the general structure of array. But if the Hertzian dipoles are placed side by side, the beam shape will not be like that because there will be mutual interaction and beams will be coupled and there will be patterns. These patterns, radiation patterns, will be multiple. So there will be some resultant radiation pattern come, and that resultant radiation pattern is phase sensitive. And giving one brief expression of resultant radiation, that equation, electric field equation. this is the expression. So in between there is a lot of detailed mathematical analysis. I am not going into details of that. So this EUP is a single Hertzian dipole placed at the center of the coordinate system. So corresponding electric field is the EUP, unit, and this is the array factor. And if we multiply this array factor with this one, we can get resultant electric field for any n number of Hertzian dipoles placed in array. Then you will get this resultant electric field. Now here you note that in this case, in this expression, this alpha is the progressive phase shift of current between the successive antenna elements. So if we intelligently manage the phase shift between the antenna elements, so resultant radiation will steer, and since there is a coupling of beams, adjacent beams, so through MATLAB simulation, we can find the resultant beam pattern and how it can be steered. The steering mechanism by changing the phase of the current, because distance is fixed, lambda is fixed, everything is fixed. So only maneuvering point is the phase of the current with which we can steer the beams, and the resultant beam pattern can be due to the this pattern multiplication of patterns. This detailed calculation are not possible in this lecture. So those who are doing research in this field, they can do some MATLAB simulation and they can obtain the resultant beam pattern for various angles, say 0 degree, 45 degree, 65 degree, the phase shift, different corresponding to different phase shift value, they can obtain different patterns, and those patterns are suitably utilized to illuminate the user equipments in case of 5G and 4G as per their necessity. So up to this point, any doubt or any question, kindly ask. Hello? Hello? Hello?
Sir, you
Yes,
proceed. Sir, you proceed.
Hello? Any problem up to this point? Any question? Because if there is any question, it will be easy for me to proceed.
But I have one, just a small query that when you form a beam from the ENB towards the EV, there are multiple antenna elements, okay, which are coherent to each other. But in the uplink direction in a mobile, these antenna arrays are absent. So while EV how the beam is formed, that is my doubt.
No. In uplink means that means you are talking about user equipment to antenna communication path.
To ENB, correct.
User equipment, as I earlier told, user equipment can house 2T by 2 word, 40 by 4 word, like that, 80 by 8 word, because the more you increase the number of transmitter and receiver, the equipment will be bulky
Correct.
And not only that, equipment will be more costly. That's why in the market you will be finding 5G handsets at different prices. Some from 16,000 to 17,000. Some handsets are available at 10,000. So that varies in MIMO configuration. But normally higher number of transmitter receivers are not there, because that will make the handset bulky and costly. And as it will be bulky, it will not be pocket friendly, not comfortable for user.
No, but the question is more technical, that in the uplink direction, how the beam will be formed. That is a question. A narrow beam is formed.
No, uplink direction, beam will be formed because that told that PMI signal is sent, and the fast mobile handset seizes the particular channel. And then, you are asking the how user equipment forms beam.
Correct.
No, the technology is same, because the way antenna array forms beam, user equipment, because user equipment does not have much flexibility. User equipment can have only 2 antennas or 4 antennas. So
That's why the beam will be very broad, while from user equipment to ENB.
No. Beam cannot be broad, because basically they are using Hertzian dipoles. And Hertzian dipole, the 3dB beam width is 70 lambda by d. That is the formula. And since in 5G we operate in say megahertz, gigahertz level, so accordingly, if you calculate what is the dimension of Hertzian dipole, that is lambda by 50, lambda by 10 to lambda by 50. Within this range is the dimension. So accordingly, beam width cannot be very bulky beam.
No, I understand that, but you see that if you have a single antenna in your user equipment, okay, the radiation pattern.
No, there is not a single antenna. It is a 40. In case of 40, four antenna. In case of 80, it is 8 antenna, like that.
Okay.
So they are also beamforming technique implied. It is not earlier generation in 2G, 3G. There used to be single antenna, but in 4G, 5G, always there is MIMO. A MIMO at user equipment end also. And while there is MIMO, there is definitely there is beamforming technique.
Yeah. One important distinguish is there, because if you want to use the MIMO configuration, your antenna element should be independent. But if you want to use it in a beamforming mode, then your antenna is a coherent. That is a basic difference between these two modes.
And then here also antenna coherent. Antenna.
But if you make an antenna coherent, then it cannot be used as a MIMO antenna. Correct?
No, why? Because in what is the basic principle? The same data stream is divided into 2 parts or 4 parts or 8 parts, equal serial to parallel conversion. So basic data stream is same. It is only divided to save the time. So their coherence must be there. Otherwise, there will be inter-channel phase difference and signal will be mutilated.
No. I think in the case of MIMO, the antenna should be independent of each other. It cannot make a coherent beam. Only in the beamforming, if you see that the antenna elements are quite closed enough so that they can form a beam. That is the basic difference between these two.
In a handset also, the antennas has to be closed.
But that is the limitation in the handset, because in a handset you have only 1 or 2 antennas. My question was that if you have only 2 or 3 antennas in the handset, how you can make a very narrow beam towards the base station? That is my question.
Narrow beam has to be there, but okay, since you are asking the question, I will study in details that.
Okay, fine.
Mhm.
Fine,
But
that's all right.
coherence and beamforming, these two basic principles must be maintained. Otherwise, the system will not function.
Yes, you're right. For the beam forming, the antenna elements are coherent. That is absolutely true. Otherwise, beam cannot be formed.
Right.
But in case of MIMO, the antennas has to be well separated. Otherwise, MIMO cannot be formed. Because MIMO is a spatial multiplexing. Those take for decoding the spatial multiplex signals. You have to have the antenna elements non-coherent.
No, but one thing you see, the handset dimension is very small. In order to make
That
it,
is a constraint. That is a constraint.
so antennas cannot be spatially apart.
Yeah. That is a basic
must be
problem.
very close. Antenna must be very close.
Yeah, that is why if you want to utilize in a MIMO technique, yeah, then you have to go for higher frequency. If you go for higher frequency, the lambda will be smaller, and in that case, your antenna will be acting as an independent. But at a lower frequency,
of course,
these antennas
I'm
will.
not entering into details of modulation technique. That would make the discussion lengthier. It is operating in higher frequency because it is 2.1 gigahertz or like that. It is in gigahertz range. So that's why the lambda is very small.
Okay. Carry on, please.
Okay. Now, so this is synopsis of my lecture. Now, further elaboration I'll not do because that will make the discussion clumsier and rigorous mathematical analysis, which is beyond the scope of this lecture. So, if you do have any further question, you can ask. Another 1 or 2 points are there with this beamforming, this uniform power is distributed in this azimuthal plane, and so it is omnidirectionally uniform power. Uniform power is there, and this thing, and the mode is the number of antenna in your phased array. Antenna G node B side, the mode will be slick, the beam, that beam will be more slick, and there will be less, it will be less prone to interference. Any further question, please?
Obirupda, you are muted. Please unmute.
Yeah. Another query comes to my mind that suppose when your base station is having, say, a big array antennas for beamforming, okay. So is the Fresnel's zone is increasing? Is the Fresnel's radiation zone is increasing because of the huge number of antennas?
No,
where you cannot apply the inverse law of distance?
Definitely, because that Fresnel radiation zone, that radius formula is very clear. That is what I remember. That is n lambda d1 d2 by d1 plus that ellipsoidal Fresnel zone you are talking about, no?
Correct. very near to the base station.
Fresnel zone has to be increased because Fresnel zone should not include any obstacle. That ellipsoidal Fresnel zone, there should not be any, because there is first Fresnel zone, second Fresnel zone, like that. There are different, depending on n. If n equal to 1, it is first ellipsoid. If n equal to 2, it is the second ellipsoid. Like that, Fresnel zones will be changed.
Got it. So that is, if that is increased because of the huge number of antenna elements, then in that area there may be, I do not know, the communication may not be possible. Very near to the antenna.
Communication will be, then there will be some diversity issue, space diversity, because reflected or scattered signals will come. But in digital, this thing, signal through digital signal processing technique, because nowadays these antennas, these antennas are smart antennas, because they are backplane, they are digital signal processors. Those digital signal processors will clean up the signal, and proper intelligence will come out of it.
Okay. Okay, thank you.
Okay.
Any question from the audience? The subject is very new, I understand, but if you have any query, you can ask.
If you do have any query, even if it's not, you can mail
from the student.
Yeah. Can you write your email on the board so that if someone has query, they can contact you?
Yes, I am writing. Madam coordinator knows it. Madam coordinator knows it, still I am writing.
Okay.
Is it clear?
Yes, clear.
Saibal Gupta 61 @gmail.com.
Correct.
If you do have any query, you can mail me. I will try to answer.
So Shoma, I think there is no question from the audience, then you can conclude.
Shaibalda, as our HOD, this is Ashik from Radio Physics.
Ashik Bolo.
So as our HOD has
Okay,
mentioned
so
that this is a topic
I
which
request
is
you to
Shoma একটু দাঁড়াও
a lot of work are
বলো
going
আশিক
on.
বলো
Yeah. Am I audible?
Yeah.
Yes.
Yes. So as I was saying that this is a topic which is very new and a lot of work are going on. So although I'm not from this domain, but what I can suggest is that it would be very beneficial for the students as well as the research scholars if at a later date we could arrange one lecture in our department. It could be sort of a tutorial, and that could be on
Yes, because Ashik Pal has established one full-fledged studio at the department.
No,
so why not utilize that studio?
No, Shoibalda, it's not yet established. We are planning for that. And hopefully in a few months we can have that. But even before that, if the HOD and the department can fix up one date. It could be on a Saturday also, so that this topic will require at least, in my opinion, 1.5 to 2 hours, and with a lot of board work. And
And
then
yes, that is the biggest problem, because from home, this is the, you see, this is the dimension of the board, and within this short board, many things cannot be properly written. No detailed
Right.
calculation can be done. So that is the difficulty. Had there been some
Right.
full-fledged studio, I could have explained in much better way. Because you know the electromagnetic theory, it is a lot of calculations are here, because it is the fully based on Maxwell's 4 equations. Those equations are the key points to start with. Here, that is the biggest difficulty. And not only that, this radio access network, it is a very crucial part. Radio access network has 2 parts. What I discussed today, that is the structural part. And there is other part, that is the content part. Content part contains the type of modulation. What does this beam convey? The convey the various signals, and signal modulation, orthogonal frequency division multiplexing. Thus, resource blocks are formed in 4G and 5G. That is the involved topics, and very interesting also. That part I could not come because of paucity of time.
Yes. So with that, I think we can plan, we can further discuss and plan maybe a 2-hour, offline.
Yes, most welcome, most welcome.
In-person tutorial like session in the department for the students, the research scholars. I think they would benefit a lot from this board work particularly, because
I also will be benefited, because research scholars, I have passed in the year of MTech in year of 1986, 1987. After that, I have personal interest in telecom matters. That's why. But research scholars are directly involved in the work. So from their questions, from their queries, I also will be benefited.
Okay. Thank you.
Hello.
Okay.
So Shamshul here. I'm from Sydney. After a long time, I've joined this kind of conference with my own institute. It's so nice to see my friend Avirup, my classmate, and all other guys in here. So I was late, sorry, to join here. Only question I have, nothing technical. Are you able to share your presentation materials with all those participants here, like some kind of email or attachment or something?
The email attachment, see, that is that is possible, but problem is that I have to take handwritten notes and photocopy, and then attach that thing, because these jargon signals, this related to electromagnetics, this computer, I don't know whether it is possible in computer. Alpha, beta, I have seen. Gamma, I have not seen. And all these things, various symbols are there. Those symbols are.
But I think you can copy into your PowerPoint presentations, all those things. I think definitely you can copy and paste on a PowerPoint presentation, because see, I'm also working in telecom industry. I got a technical industry knowledge, more than 32 years. But not in R&D area, to be very honest. We are implementer in the industry, and we work in that area. So maybe your technical, all those Maxwell equations, I left when I left BTech.
Maxwell equations,
Professor Biarnack's class
cannot be and should not be forgotten. That is the Gita of telecom.
No, I'm not telling I have forgotten, but I left it there once I left Professor Biarnack's class. I never need to look back in. But obviously we are the user, and we I'm working with Tata,
Because
and Telstra in Australia.
Maxwell equations are the starting point of all the things.
Of course. Now I'm not going into that. What I'm trying to say, I left it there. I never tried to study those materials or equations in my brain.
Had there been no Maxwell's equation, we could not get idea about magnetic vector potential. See, after MTech, for a short period, I entered into IIT Kharagpur for that PhD work, but PhD work could not be completed as I got offer from DOT, IBS offer. So during that time, my guide used to tell that what is electric field, what is magnetic field. These all are fluctuations of magnetic vector potential. So magnetic vector potential is the key idea. And how could we get the idea of magnetic vector potential? From Maxwell's equation only.
Of course, but I'm feeling really I'm connected into that level again, which is really interesting. But anyhow, the thing I'm trying to say, if I can able to share those presentation materials, I could able to revoke my memory and try to understand.
Definitely, I will try. I will try.
Thanks for inviting me. That is great. I love it.
Another.
Be patient. I think Mr. Gupta will send that thing to you.
Sure.
Another suggestion, since Ovirup is here. Since Ovirup is here, I am having another suggestion. Because there are a lot of BTech students might be listening this session. These BTech students, some of them are interested for MTech and they have to qualify GATE. So for GATE also, this studio can be utilized for GATE-related problems and discussions on GATE-related questions, etc. That is my suggestion to Ovirup.
Yes. Yeah. Of course, all
the BTech students may not be interested, but few of them may be interested for MTech.
So may I ask another question to you guys, like Ovirup and the organizer? What are the topics people can talk about?
they can talk,
4G,
or
5G.
even popular technical lectures also can be accommodated here.
Actually, my first preference is electromagnetic EMFT, electromagnetic field theory, whatever is including electrostatics, electrodynamics, whatever things are there, I am comfortable with. You can think in terms of Professor Biaren and Sitesh Roy. These two.
Yes, absolutely. No, I'm saying I do not have that kind of working experience, but I have some voice over IP.
Samsul.
Yes.
Samsul, in the next Saturday, I hope there will be a talk on regenerative AI, artificial intelligence.
Ooh, that will be interesting.
Maybe some of our alumni will give.
Okay.
Yeah. So we will circulate that among our group. Okay. Once we finalize that.
Who is giving a lecture on regenerative AI?
Shorvani Maiti from Database.
I think Shoma can tell.
Shorvani Maiti from Database.
That is very interesting topic.
Absolutely. Yep. Great. No, that is very interesting. Sure.
I will circulate in the group.
Shorvani Maiti. She will give. Yeah. So that is a very interesting topic.
Any MATLAB based work is going on in regarding antenna?
So like this, we want to grow this.
Now Devotas has got some laurel that is
so
really praiseworthy.
use some software, those people who are directly
Actually,
no, actually antenna-based work, they use some
MATLAB simulation will
ready-made software like HS. Really interested in modeling.
But those who are doing
MATLAB
research
simulation
work,
is possible.
they
It is
must
not like
be-
that, but it is
they
quite
must
cumbersome.
They must be using.
Actually,
They must
but
be
even
using
MATLAB has some library. You can use those things also in antenna. Yeah, many people are using MATLAB. Many in other domain also.
Because these antenna patterns, etc., without MATLAB, it cannot be foreseen.
Yeah. MATLAB actually, you see that with one dimension, it is very easy to plot. But when you have 2 dimension, it is quite a cumbersome, and 3 dimension is totally a mess. So people are accustomed to use some other kind of software which can give them a better understanding. But MATLAB can be used. I have used in some occasion this MATLAB for array antenna simulation and like that. So it's possible.
So I request Professor Dashbarman to conclude the session.
Yeah, so I think, Shoma, I think there is no question. So can we conclude now?
Okay. You can conclude.
So we must give a thanks to Mr. Saibal Gupta for delivering his nice illuminating talk. And we also invite him to come to our department and directly interact with the students.
Definitely. On 22nd,
Yeah.
I will come and I will meet with you.
Okay.
So, Saibal, the last question. This is not a question, just a query. Which year you passed out from radio physics?
BTech 1984, result 85, MTech 86, result 87.
Okay. Okay, so you basically 86.
I was the first gate batch.
Okay.
Suddenly I saw one poster on CS building wall that gate exam is going to be conducted. Fill up the form. Those days there was no computer, nothing, no mobile. Very difficult days. But just seeing that advertisement.
Got it. Yeah.
And you are working with a DOT, right?
That time there was no BSNL, DOT. Later on in the year of 2020, it became BSNL.
Okay.
No, it was just 1st October.
No, great to know that. Thank you very much.
Okay, most welcome.
I think that is all from us, from all audience.
Okay, Shoma, can we conclude now? Yeah.
Okay, thank you.
ঠিক আছে শৈবাল দা, তাহলে আজকে এখানেই শেষ হোক। হ্যাঁ,
ঠিক আছে।
ওকে সোমা, তাহলে আজকে সবাই লিভ করছি তাহলে। সোমা কি শুনতে পাচ্ছেন না? মিউট হয়ে গেছে। Okay, Samsul, thank you for joining.
No worries, I think we are all good.
Yeah. Thank you for joining.
No, it was my pleasure to see you and Saibal and all young boys and Shoma. I never met her. I heard her name.
He's just 4 years junior to us.
My network is.
Yes. I heard about her, and she's the teacher of in Rafael now, right?
No, which year you have passed? Which year? What is your BTech batch? Your year of passing?
Same as Ovirup.
Samsung 1990. 91 pass out.
Yes.
91. We are in 94. Mine is 94. BTech 94.
Yeah. We might have
Okay.
seen each other during your fresher, but I can't remember your face, to be very honest.
Yeah, come to reunion from Sydney.
Okay, I'll come.
Next time, not this year. You have to make it in January or December or
Okay.
January. I just came back from Calcutta.
Okay.
No, definitely. The next time I must try, but I would love to join in this kind of interesting course. Maybe I'll be not understanding much, but I'd love to be there to see,
Okay.
to be part of this.
Thank you, Samsu.
Okay.
No, thank you. You organized all, you did the hard work. And Soma, of course.
What get it to go to Soma?
Now, on behalf of organization of the Radio Physics and Electronics Association, I am organizing, but on behalf of the association.
No, that's great. Many to come. I'm sure that will benefit not only students, but all of us.
Okay. So, okay, can we leave now?
All right.
Soma?
Good night.
Okay. So, okay.
Okay. Bye.
Bye, everybody.